largest solar storm in over 2 decades. We're talking about Northern Lights here. It's upgraded its geomagnetic forecast for its highest intensity level.
Something just happened that hasn't occurred in over 20 years. The sun unleashed a radiation storm so powerful, it nearly knocked out power grids across North America. We got lucky. The magnetic field pointed the wrong way for disaster. But here's what keeps scientists up at night. We're heading into the most active phase of solar cycle 25, and the next storm might not miss. Right now, sunspots are crackling with energy that could dwarf what we just experienced. And if the magnetic field flips the other direction when it hits, we're looking at technology failures, satellite losses, and blackouts that could last for weeks. The clock is ticking, and the sun isn't done with us yet. Just days ago, Earth took a direct hit from a solar storm that scientists are calling near Carrington class.
A powerful solar storm on Earth, and it's the strongest since 2003.
That term should make your blood run cold. The Carrington Event of 1859 was the most powerful solar storm ever recorded. Telegraph wires burst into flames. Auroras lit up the sky all the way to the Caribbean. If that happened today, we'd be looking at $2 trillion in damage and a decade of recovery time. But here's the thing that's got the scientific community buzzing. We dodged a bullet, and most people don't even know it happened. This wasn't just another solar flare, this was a monster. The magnetic field strength hit 90 nanoteslas. To put that in perspective, normal space weather sits around 5 nanoteslas. This was 18 times stronger than baseline. The solar wind screamed toward us at 2.6 million miles per hour. The only reason you're watching this video right now, the only reason your phone works, the only reason the power grid didn't collapse, comes down to pure chance. The interplanetary magnetic field had a positive orientation. Think of Earth's magnetic field like a shield with a specific polarity. When a solar storm arrives, it carries its own magnetic field. If those fields align the same way, they repel each other. That's what happened. The storm's magnetic field was positive, matching Earth's orientation in that region. So instead of connecting and dumping all that energy into our atmosphere, most of it deflected away. But if that field had been negative? Here's where it gets technical, but stay with me because this is critical. Earth's magnetic field protects us like an invisible force field. When a solar storm hits with a negative magnetic orientation, something called magnetic reconnection occurs. The storm's field lines and Earth's field lines snap together like magnets. This creates a direct pipeline for solar energy to pour into our upper atmosphere. That energy doesn't just disappear, it flows into power lines, transformers, and electrical grids. It fries satellites, it disrupts GPS signals. It can literally melt the copper windings inside massive power transformers that take months or years to replace. The Geomagnetic Storm Index, called KP, measures magnetic disturbances on a scale from 0 to 9. During this event, we hit 8.67. That's G5 territory, the highest category. For 1 hour, we were in G5 plus conditions. If the magnetic field had been negative, scientists estimate we would have sustained the strongest solar storm since at least 1989, possibly since 1859. While everyone was watching the pretty auroras, something else was happening that poses an even bigger threat. The sun unleashed an S4 radiation storm. That's the first time we've seen radiation levels that high in over 2 decades. And we came dangerously close to hitting S5, a level we've never officially recorded since we started measuring this data. Most people don't understand what a radiation storm actually means. Radiation storms aren't like regular storms. You can't see them, you can't feel them, but they're absolutely devastating to technology. High-energy protons from the sun come screaming through space at nearly the speed of light. When they hit satellites, they can flip bits in computer memory, causing errors. They can damage solar panels. They can permanently destroy sensitive electronics. For astronauts in space, this is a life-threatening event. The International Space Station has special shielded areas where crew members take shelter during radiation storms. Without that protection, they'd receive dangerous doses of radiation in hours. But here's what really concerns scientists about this particular storm. The proton flux, which measures the number of high-energy particles hitting us, spiked to levels we haven't seen since the Halloween storms of 2003. Those storms caused widespread satellite failures, knocked out power in Sweden, and disrupted air traffic across North America. The radiation was so intense, that airlines had to reroute flights away from polar regions where passengers and crew would receive excessive radiation exposure. This time, we reached S4 levels. The threshold for S5 is 100,000 proton flux units. We got close, but didn't quite make it. That might sound like good news, but it's actually terrifying. Solar flares accelerate particles to incredible speeds. Protons, which are just hydrogen atoms stripped of their electrons, get flung into space like bullets from a cosmic shotgun. The most energetic ones can reach 500 mega-electron volts or higher. At those energies, they can penetrate deep into materials, causing what's called a single-event upset in electronics. Think of it like this. Your computer's memory stores information as ones and zeros. A high-energy proton can hit a memory cell and flip a 1 to a 0, or vice versa. In a satellite's navigation system, that could mean the difference between knowing where you are and being completely lost. In a power grid control system, it could trigger a cascade failure. The really scary part? These particles arrive in minutes, not hours or days like the main solar storm. There's almost no warning time. During this event, the radiation storm peaked and then declined over about 24 hours. We're now back down to S1 levels, which is manageable. But the sun isn't done. The sunspot region that produced this flare is still active, still growing, and still crackling with magnetic energy. Scientists are watching it closely because all the signs point to another major eruption coming soon. And next time, we might not be so lucky with the magnetic field orientation. Here's something that's going to sound crazy, but the data backs it up. During and immediately after major solar storms, earthquake activity increases. And right now, California is lighting up like a Christmas tree on seismographs. Just as the solar storm was hitting Earth, a magnitude 4.9 earthquake struck Southern California near the San Andreas Fault. That's significant, but what happened next is even more concerning. In the hours following that quake, over 200 smaller earthquakes rattled the same region. That's called a swarm, and it's often a warning sign. The San Andreas Fault is overdue for a major earthquake. The southern section hasn't ruptured in over 300 years. Stress has been building. And while scientists debate the exact mechanism, there's growing evidence that solar storms can act as a trigger for earthquakes in regions that are already primed to go. Solar storms create massive electrical currents in Earth's upper atmosphere and even in the ground itself. These are called telluric currents, and they can flow through rock and magma. When you pump electrical energy into a fault system that's already under tremendous stress, it can act like the final straw that breaks the camel's back. Think of it like a boulder balanced on a hillside. It's stable, but barely. A small push could send it tumbling. Solar storms might be that push for earthquake faults. The magnetic field fluctuations from a solar storm induce electrical currents in anything conductive, including the Earth's crust. These currents can heat rock, change pressure conditions, and potentially trigger seismic events in areas where faults are already close to failure. The correlation isn't perfect, but statistical analysis shows a measurable increase in earthquake activity during and after major geomagnetic storms. California just experienced both a major solar storm and increased seismic activity. Coincidence? Maybe, but scientists are paying attention. The earthquake swarm in Southern California is ongoing. Most of the quakes have been small, under magnitude 4, which suggests this might just be an aftershock sequence. But swarms can also be foreshocks, warning tremors before a much larger event. With the San Andreas Fault capable of producing magnitude 8 earthquakes, and with solar activity ramping up, this is a situation worth monitoring closely. The sunspot region that caused all this chaos is still there, still growing, and showing signs that it's about to erupt again. In the past few hours, scientists have observed what they call crackling activity, electrical arcing between different sunspot groups. That's usually a sign that a major flare is imminent. We're in solar cycle 25 and we're approaching solar maximum, the peak of the sun's 11-year activity cycle. Solar maximum for this cycle is predicted to occur in 2025 to 2026. That means we're entering the danger zone right now. The sun is going to throw more and bigger storms at us over the next year or two. And here's the critical point. We can't predict the magnetic field orientation of a solar storm until it's almost on top of us. We might get 30 minutes of warning, maybe an hour. That's not enough time to do much except brace for impact. Scientists are watching for another X-class flare from the same active region. X-class flares are the strongest category, and they can launch coronal mass ejections, the massive clouds of plasma that cause geomagnetic storms. If we get another long-duration X-class flare in the next 24 to 72 hours, and if it launches a CME directly at Earth, we could be looking at a second major impact. The transit time for the last storm was about 30 hours. That's fast. Most CMEs take 2 to 3 days to reach Earth. A 30-hour transit means the plasma is moving at extreme speeds, carrying more energy. For most people, the immediate risk is technology disruption. Make sure you have backup power for essential devices. Keep some cash on hand in case payment systems go down. If you rely on GPS for work, have paper maps as backup. If you're in an area prone to power outages, stock up on basics like water, food, and batteries. For the bigger picture, this is a wake-up call. Our infrastructure is vulnerable. Power grids need hardening. Satellites need better shielding. We need better space weather forecasting. The technology exists, but it requires investment and political will. The next major solar storm could hit any time in the next few days, weeks, or months. When it does, we'll have minutes to hours of warning. The question isn't if it will happen, but when and whether the magnetic field will be oriented to cause maximum damage or deflect most of the energy away. The sun is waking up, and 2026 is shaping up to be a year of extreme space weather. The near miss we just experienced should be a warning. We came within a magnetic field flip of experiencing the worst technological disaster in modern history. Power grids, satellites, GPS, communications, all of it could have gone dark. And scientists aren't fear-mongering. They're reading the data, and the data is clear. Solar cycle 25 is proving to be more active than predicted. Radiation levels are reaching heights we haven't seen in decades. And the infrastructure we depend on every single day is more vulnerable than most people realize. The good news? We're getting better at monitoring the sun. We have satellites watching it 24/7. We have models that can predict solar storms with increasing accuracy. And we're learning how to protect our technology from these events. But knowledge only helps if we act on it. The next big one is coming. The only question is whether we'll be ready when it does. Hit that subscribe button and turn on notifications so you don't miss updates when the next solar storm hits. I'll be covering it in real time. Drop a comment below and let me know. Are you prepared for a major power grid failure? What's your backup plan? I read every comment and I want to hear from you. Finally, share this video with someone who needs to see it. Maybe it's a friend who works in emergency management or a family member who thinks this stuff is just science fiction. The more people who understand what's coming, the better prepared we'll all be. Thanks for watching, and I'll see you in the next one.